What does it really mean for an AI to think? Today, we're diving deep into large language models, our infrastructure. Software is rewriting itself through natural language. LLMs shift logic from explicit code to conversational prompts. Every application layer from database to UI now negotiates with a language model. The interface becomes the application. Language is the new universal API. Strategic implication: businesses retool for probabilistic execution and continuous adaptation. Every digital product now has a language model-shaped whole. Adoption velocity surpasses prior platform shifts. But here's where it gets interesting: the reliability gap. Raw model output fails in production environments. Hallucinations inject plausible falsehoods that compound across workflows. Parametric knowledge drifts stale. No live connection to ground truth. Context windows limit multi-step reasoning for complex enterprise tasks. Prompt engineering alone masks failures; it cannot resolve them. Traditional testing can't catch probabilistic failures. New validation paradigms are required. High-stakes deployments remain blocked by trust and accuracy thresholds. So what's the real problem? Let's talk about the stateless core. Autoregressive transformers lack external grounding mechanisms. Decoding maximizes next token likelihood, not factual correctness. Parameters encode a fixed snapshot. There is no retrieval loop during generation. Reasoning and knowledge are conflated in the same forward pass. No architectural separation between language understanding and factual verification. Without grounding, the model is a brilliant but unaccountable oracle. This raises a critical question: the limits of scale. Larger models did not solve the grounding problem. Parameter growth improved fluency, but hallucination rates plateaued. Emerging consensus: raw scale alone cannot deliver production reliability. The frontier shifts from monolithic models to compound AI systems. Compound systems orchestrate models with retrievers, tools, and verifiers. This architectural pivot enables controllable, auditable, and updatable intelligence. The community now treats models as components within larger engineered systems, not standalone oracles. Now let's zoom in on augmented generation. Extend the model with retrieval, tools, and structured reasoning. Retrieval augmented generation (RAG) grounds outputs in fresh external evidence. Tool use integrates procedural precision calculators, code executors, SQL queries, chain of thought, and tree of thought. Make intermediate reasoning transparent and auditable. Memory architectures give the model state across interactions. The LLM transitions from a knowledge repository to a reasoning coordinator. This architectural shift defines the new state of the art. Here's something most people overlook: the augmented LLM stack. A layered architecture for reliable language applications. Layers: interface layer, input processing, context window management, output formatting orchestration layer, prompt assembly, tool routing, memory coordination, policy enforcement model core, foundation LLM, serving as reasoning engine grounding layer, vector retrieval, knowledge graph queries, live API connectors, safety layer, content filtering, factual consistency scoring, output validation, alignment guardrails. Each layer is independently scalable, testable, and replaceable. Think about this for a second: core system components. Modular building blocks that operationalize accuracy. Retriever: hybrid dense sparse search with relevance re-ranking over enterprise corpora. Tool executor: sandbox code interpreter, API connectors, structured data query engines. Memory manager: episodic conversation state, semantic long-term profiles. Working memory buffer. Policy engine: rule-based and model-based guardrails for toxicity, PI, and domain compliance. Evaluator: real-time hallucination detection, grounding score, output factuality check. These components compose into verified pipelines. The modularity allows independent scaling per workload demand. And this is where things get complex. The agent loop. Every query initiates a verification and action cycle, workflow, query classification, and intent routing. Parallel retrieval from knowledge bases and tool, discovery prompt assembly with context, instructions, and memory model generation with structured output, parsing tool execution for computation, data lookups or code result, integration and grounding verification. If confidence below threshold, loop to step 2 with refined query final response with citations and confidence indicators. This loop reduces ungrounded outputs by an order of magnitude. But here's where it gets interesting. Measuring certainty. New metrics replace BLU and perplexity for production systems. Factual consistency score. Alignment between output and retrieved evidence. Grounding ratio. Proportion of claims backed by a source. Task success rate. End-to-end completion of multi-step objectives. Hallucination rate. Frequency of unsupported assertions per output. Latency budget per reasoning cycle, maintaining real-time interaction. Human evaluation for factuality becomes expensive. Automated metrics enable scalable oversight. Continuous dashboards track these metrics per deployment. So what's the real problem? Let's talk about from prototype to production. Augmented systems unlock enterprise-grade AI deployment. Regulated industries, legal, healthcare, finance achieve 95% accuracy in document analysis, coding, and reporting. Complex workflows become autonomous, contract review, claims processing, compliance monitoring. Audit trails and citation maps satisfy regulatory transparency requirements. Cost per reliable decision drops by 100x compared to manual review. Early adopters report 80% reduction in manual review cycles. The gap between demo and deployment closes permanently. This raises a critical question. Autonomous agents emerge. The augmented stack evolves from reactive answering to proactive task execution. Multi-agent systems. Specialized agents collaborate, decompose goals, and negotiate. Continuous learning. Retrieval indexes update in real time. Models adapt through fine-tuning loops. Small language models. On-device inference for low latency. Private edge applications. Self-improving loops. Agents critique their own outputs and refine strategies. Regulatory frameworks begin to require these augmentation patterns for high-stakes AI. The trajectory, from copilot to autopilot for digital work. Now let's zoom in on the language OS. LLMs become the operating system for digital tasks. Natural language is the new command line, the universal interface. The augmented stack abstracts reasoning, retrieval, and action. Every software category is being re-platformed around language intelligence. The strategic imperative: build the orchestration layer, not just the model. Organizations that master the augmented stack will define the next computing platform. This is the infrastructure moment for AI. The next decade belongs to systems that turn language into verified action.